My name is Fabien Ferrero. So as you can see, I'm not the person who was supposed to do the presentation. So Rich Nguyen apologized because he was not able, in fact, to get the visa to reach Amsterdam to do the presentation. So I'm doing the presentation in this place. This work has been mainly done by University of Virginia. And the objective of this study is to predict urban flooding in smart cities. And especially, so this is an international collaboration, so you can see that I'm on the second picture, but more widely, this is involving several universities, so both University of Virginia, myself, University Côte d'Azur, and also several universities in Vietnam, so University of Da Nang and University of Ho Chi Minh City. So why is this international collaboration? Because the objective of this study is to develop some solution to predict flooding in Vietnam. So why in Vietnam? Because Vietnam is well-known country to get a lot of issue with flooding, and each year you get some people that are dying because of the myth of flooding prediction. And so you get some picture, but just to tell you that all over Vietnam, this is really a big mess because it's a tropical region, and when the rain is coming, it's not just raining a small amount of water, it's really huge. So here, the objective is to find a way to find a simple way, smart and sustainable, to predict, and especially also to alert about flood risk as early as we can, and as fast as we can. So how to predict and alert? So of course, sharing a paper map or just using a megaphone has been the classical way, but it's not really appealing and not really scalable. So the idea is really to integrate all this information that we can gather in a digital map and to be able to predict for tomorrow or in a month or just in the next hour what is the risk of flooding. So the objective is to build a robust hardware and software infrastructure. So it takes a lot of effort. So the idea is really to be based on just a smartphone web app. So the idea is just to be able to have a simple application where you can connect from your smartphone. And in Vietnam, most of the people get a smartphone. And it's a very convenient way to share this information among all the population. And the idea is to build, analyze and build a predictive model that, of course, is using a huge amount of data. And in order to compute this huge amount of data, they are using AI-enabled, artificial intelligence-enabled service. So basically, the FloodWatch is a platform that is using data from different data sources. So I will explain later on what type of information we can gather. The idea is to use this data to make, analyze, and model, and then to be able to broadcast to multiple users the prediction, and then also to be able to identify some scenarios, and so that the city, the government, and so on can get some solution to mitigate the risk of flooding. So it supports peer-to-peer, Wi-Fi 4G, and LoRaWAN and cloud infrastructure. And of course, we are using AI to provide a timely access to the flooding data and to the forecast. And the idea is really to broadcast the information on a map-based platform to share the risk of flooding. So here is the main source of the information that we can gather. So first, we are using data from IoT sensing. So this is exactly what we are doing here in this conference, meaning that we have deployed some IoT sensors, and I will show one of the sensors we have developed for this application. We're also using data from existing meteo station and everything that you can find. So, for example, at this time, they're also trying to use information that they get from camera in the city to analyze the picture in the camera and to predict and to see if some flooding are coming or the amount of water in the street. And they're also relying on the community-based, so meaning that any people that is using the platform can also contribute and give some information and shared, in fact, if he's doing some flooding coming, so meaning that all the data shared by citizens. So it can be pictures, it can be text information, it can be social media, everything that can help to predict. So I will first start, of course, on the IoT sensing infrastructure. So this is a very classical infrastructure, a classical LoRaWAN infrastructure. We have the sensors that send the information to gateway, that forward to the network server, and send it to the application layer to do the map compilation, and to the FloodWatch application. So the FloodWatch user gain access to the aggregated data shared by all the weather sensors. And also, we are piloting automated data infrastructure with people in Ho Chi Minh City. And the idea is to help the people to host the data and to control which data are shared to the community and which party keep for later use, like publication. So if I come to the LoRaWAN sensor, we have been developing especially for Da Nang, which is a city where a lot of LoRaWAN gateway have been deployed. So especially with me and University of Da Nang, we have been developing rain sensor. So you can see that it's really based on a very simple. So certainly, if you have been using some meteo station, you know this type of sensor. It's a very simple and very let's say, basic rain sensor based on mechanical system. So we just take these sensors. Usually, this sensor is connected to a meteo station. So in fact, what we did is just we place inside this sensor directly all the electronic, so LoRaWAN transceiver, and also the antenna. And when the rain is falling, you can count the number of time the system is triggered, and from that you can guess what is the amount of rain that. And then it can continuously send the information to the application, and you can know in a very accurate way which amount of rain has been falling on a specific area. So we have now more than 20 sensors like that deployed in Da Nang, and we are really starting the experiment. We call it the low rain gauge, and you get here all the different parts. We plan to open source all this equipment so that anybody can or build it yourself or make it for a very cheap price. So the application looks like that. So if you go to the floodwatch.io, you will find this application, and you see a map of the Vietnam with the colors is giving you the risk of flooding for a given time. So you can select if it will be for tomorrow, for the next week, or for later on, and it will give you the risk of flooding. So the prediction is not only based, of course, on the actual sensor, it's also based on the historical weather data that has been collected for more than 10 years. And they are running an AI service that, from the prediction of from the history, can predict the risk of flooding. So it concerns more than 5.2 million of data points that have been analyzed in the 65 major cities in Vietnam. They also collect the 210 recent flood events to analyze and to create some model to be able to predict in a more accurate way the risk of flooding. And of course, they are training several AI prediction models to increase the accuracy. So if you go on the map, you can click on any position in Vietnam, and you will get a risk of the flooding risk prediction. So this application is running now. You can test it. It's very easy to use because it's really map-based, meaning that you have a direct view of, you can zoom on the different cities, you can play with it. And also, you have now live the sensors which are connected. You can click on the sensor and you can see the historical data of the rain sensor. The sensor also integrates on temperature and humidity, so additional sensor data that are provided. And then, last but not least, the objective of this work is also to use data shared by citizens. So the idea that anybody can use the apps to provide some information, and especially, so the notion of live crowdsourced fraud report present a new perspective. And also, this is a way to involve the people. You know, if you are using, you also want to contribute. If you think that this application is useful for you, this is also something where you can contribute to the community and help to improve the prediction. So it's a sort of civic involvement. So there is multiple ways to share the data, such as numeral rating, textual review, coordinate location, and also what they have been doing is just image. So meaning that you can take your phone, you take a picture, and they have developed some AI solution to analyze the data and to understand if it's a flooding risk, and also to use it for the application. So how to know if the shared images are appropriate and useful for flood prediction? The validation is done like that, meaning that from the picture, they use a neural network to make a prediction if the image represents a flood or not. And then if it represents a flooding, they will use the data and use the geolocation to use this information for the prediction. Just to tell you that this work has been published and it received an outstanding paper award in an international conference because of the work which was presented. Okay, so just to summarize this presentation, so as you can understand, this flooding is not based only on one source of information. The idea is really to have a multimodal, so to use data from IoT sensing, so as we can provide in the LoRaWAN ecosystem. Also using the data available from the web, so it can be, as I mentioned, meteo station, but also camera that are available in the city. And also contribution by the user, so the citizens, that can, and thanks to these three different source of information, we think that it's really possible to improve the accuracy of the prediction. So some future direction in this app, so it's a research project, so it's seen in evolution. So the idea is also now to extend to largest metropolitan area. And then, of course, they will be starting with Vietnam, but the objective is to extend to all Southeast Asia and probably later on to the world. So they are currently installing and registering remote sensing devices like this one, and they will be deployed all over the country. Now it includes mainly rain, humidity, and temperature, but the idea is to add more sensors. Like, for example, if we are close to the river, we can have some radar flowing system to understand if the level of the river is rising, for example. This is also something which is under study. So water level, water quality, air quality data. This work, of course, was first dedicated to flooding. But imagine that this type of map and AI predicting model can be applied to a lot of different applications, like, for example, real-time traffic monitoring, which will be under study in the future. So it can be compatible with any existing apps because they are providing API to be able to integrate data for any source. So the idea is for the next step is to move from the full watch to something more generic, including water quality, water level, air quality, traffic, and then the flood watch will move to something like smart city watch that will provide more information to the user. So thanks a lot for attending to this presentation, and I'm here if you have some questions. Thanks a lot. I don't know if there is a question. So we don't have time for question. OK, thanks a lot. Thanks.